In this video, I'll be going through the deep learning project that I've worked on using the machine learning repository from UCI on the heart disease dataset. So I have divided this project into three groups. The first one is the data analysis and pre-processing. The second one is pretty much making the data suitable to use in the model itself. And third one is all about the deep learning network that I made and ran experiments to determine what uh, parameters gives the best result, the accuracy for the model. And another thing that I've done is in each of the section before I started, I wrote what my plan was. So as you can see, this was like pretty much my plan. So I started with this, but if I made some changes after seeing the results, and I've mentioned the changes afterwards. So I pretty much just imported the data and dropped the columns that wasn't really necessary. And there were some data that weren't numerical, so I converted those data to numerical data. Yeah, the data analysis was not really that big of a deal, but there was a lot of missing values. So as you can see, I used this is a really fancy tool, I think. So I used this library to fill out the missing values because I didn't want to drop any columns because any rows because the dataset is not that big at the first place. It only has 920 columns. I mean, sorry, the 920 rows, and you're going to train probably 80 to 85% of that to use to train. So it's going to go even less. So instead, I replaced the missing or null values with uh, for a few columns I've used median, and for other columns I've used mode. So median, I've used median for columns that has numerical values, and I've used mode for columns that has categorical values or binary values. So those columns, I guess it makes sense, not much of a big deal. Uh, then obviously, so this is the next part. So preparing the data to use it in the model. This is again pretty straightforward. Just I split the data, took 85% of it for training. I normalized the data, obviously. Yeah, that was pretty much it. Then, of course, I'm using PyTorch, and I'm also using batch training. Yeah, so in order to do that, I'm using tensor dataset and train loader with a batch size of 16. And there is batch size for the test data is pretty much the entire size because I'm not going to test batch wise because there isn't a lot of data in the first place. But next comes to the network. Next week come to the network. So at first, I planned that there's going to be, of course, an input layer and three hidden layers 16, 64, 16, and then output layer. And originally, I was going to make this a multi class classification problem. So there will be people with no disease, people with low to moderate disease risk, heart disease risk, and people with moderate to high disease risk. But the problem is, if I converted the data into three classes, then the data becomes really, really unbalanced because the number of people with no disease in the data is really, really high. So instead, I changed the data to a binary classification to where I'll predict whether a person will have any risk of disease or no risk of diseases at all. And I think I mentioned it, but yeah, but after I experimented with this architecture, a few things happened. First of all, I think I mentioned these things, right? Changes. So having three hidden layers was redundant as there were only, yeah. So there wasn't really a lot of data in the first place. So having three layers made the model learn a lot, basically memorize. So it was overfitting a lot. Then I changed it. I only added one hidden layer with 32 nodes. I don't know where the number came from. Secondly, I initially thought that I'd be using L2 regularization because it's a literally a very simple tool that makes your model perform really, really well. But then again, it wasn't really doing much. I mean, it did improve, but I feel like it could be better. So instead, I did not use L2 regularization and opted for what do you call it? A dropout regularization. And I ran an experiment, and that told me that if I use 50% dropout rate in the hidden layer and only 0 to 10% dropout rate at the output layer, that literally gives the best result. And there is no overfitting at all. Pretty much no overfitting. In fact, the test accuracy is like gets so much better than train accuracy. Not so much better, but a little better. Yeah. Then another thing is I'm a big fan of batch normalization. I use it all the time. I mean, I haven't been in the deep learning space for a long time, but I like it. So far in practice, it gives better result. But for this case, it wasn't really giving better results. I don't know why. But then I realized that, oh, when I learned batch normalization, I learned that it is used for deeper networks. And for deeper networks, it works really, really well. But I have only one hidden layer, so it made sense. That's why I got rid of it. I think another thing I should add is I changed the model architecture uh, based on binary classification. I guess I should add that because I forgot to add it. Then comes the model. As you can see, one input layer. Initially, I did normalize, but I didn't use it, so that's fine. So one layer and one output layer. Then there's the forward function. So this is the input layer. After the input layer, I'm setting a dropout rate of 50%. So here's the first hidden layer. There's only one hidden layer. And after the first hidden layer, before the output layer, I'm using a dropout rate of 10%. And then I pass it through the output layer. And of course, I'm not using normalization, as you can see. And of course, it's a binary classification. So I'm using BCE, binary cross entropy. And another interesting thing is, as you can see, I'm using S standard gradient descent now. Why am I not using Atom or RMS prop? I've used those, and I don't know why, for some reason, standard gradient descent is giving me better result. I just like what it gives me, you know. So again, it's all about experiment. I ran a lot of experiments. I literally stayed awake all night to like just run experiments and see what works better. Then I set the number of epochs 500. Now, previously I set it 1000, but it wasn't really necessary, I guess. Then you have training accuracy, test accuracy. So these will save the accuracy throughout each epochs. Then the actual training. So setting the model in training mode. And of course, batch training. So iterating to the train loader for training the model. And this is where I like for each epoch, getting the training accuracy and test accuracy and appending to these and returning the model instance, the training accuracy and the test accuracy. So here is the like this is just to see if it's working or not. So as you can see, the red curve is the curve of the learning or the accuracy of the training data for each epoch from 0 to 500. And the green one is for test data. And surprisingly, the test data is like doing pretty good, and the training data is not overfitting. So that is really nice. And also, the training data, as you can see, is still going upward. So I'm assuming if I ran this experiment, I'm not assuming, I saw if I ran this experiment a few couple of hundred more times, then these two line pretty much get submerged together, the green and the red line, the training accuracy and the test accuracy. So this is, I basically saw the average of test accuracies for the last 100 epochs. So that came out to 90%. So that's pretty good. Then I ran one last experiment, which is I basically got 10 models. I got their training accuracy of the last 50 epochs and the test accuracy for the last 50 epochs. And as you can see, the training accuracy is somewhere around 86%, pretty much 86%, and test accuracy is somewhere between 88 and 90%. And I think it's kind of obvious that, as you can see, the training accuracy was still going up. You know? So this explains why this is a little less. And obviously, if I ran it a little bit more, maybe 700 epochs, I'd pretty much get around 88%. So again, heart attack disease prediction, I know it's not a revolutionary or pretty hard, but the goal was this project was to implement the things I've learned so far and see how they're working with real data. And the running the experiments like gave me a lot of insight about the things, the theory that I've learned, and like what I've learned so far really reflected on this project that I've made. So yeah.